Ideas germinate. We support our students to become entrepreneurs and help them cultivate it to bring about revolutions of change. At RKU, they are the nucleus, surrounded by a circle of learning, nurtured by hands of knowledge. By giving them a global exposure, we allow understanding to seep through project-based learning. They get their hands dirty, assess real situations, unfold new theories in our labs, and find holistic answers to every hurdle that comes their way. Interweaving happiness and learning, the university provides a vibrant atmosphere to fashion well-rounded personalities who are people of thought, people of freedom. Powered by spirit of inquiry, they move into the world on wise words and firm foundations. Each day, they pave a path that arches forward for themselves and those that will follow. At RKU, we make worlds meet. We craft trailblazers who shape better futures. We look forward together, standing firm on today's lessons and the possibilities of tomorrow. For the world is not our oyster. The universe is. We are a curious lot. We search, invent, seek, explore till we uncover answers. Change drives us. From the moth to the butterfly, from the clay to the pot. That is why at RK University, we educate through discovery. We shape thinkers and self-learners, making knowledge an exciting journey. Opening new doors and steering into new horizons, our students are a generation of tomorrow, a timeless tribe of change makers. When the fire burns within them, we rouse it to scale greater heights. When ideas germinate, we support our students to become entrepreneurs and help them cultivate it to bring about revolutions of change. At RKU, they are the nucleus, surrounded by a circle of learning, nurtured by hands of knowledge. By giving them a global exposure, we allow understanding to seep through project-based learning. They get their hands dirty, assess real situations, unfold new theories in our labs, and find holistic answers to every hurdle that comes their way. Interweaving happiness and learning, the university provides a vibrant atmosphere to fashion well-rounded personalities who are people of thought, people of freedom. Powered by spirit of inquiry, they move into the world on wise words and firm foundations. Each day, they pave a path that arches forward for themselves and those that will follow. At RKU, we make worlds meet. We craft trailblazers who shape better futures. We look forward together, standing firm on today's lessons and the possibilities of tomorrow. For the world is not our oyster. The universe is.
Welcome back to all the participants to day 4 of this online lecture series regarding research methodology by RK University. Sunday evenings can also be utilized for some healthy learning as well. And so here we are. We have crossed the halfway mark in our research journey. We looked into the crucial aspects of research ethics and research design on day 1. On day 2, we looked into review of literature and reference management tools. On day 3 yesterday, we learned about drafting a research proposal, followed by computing in data mining and analysis. We now move on to the first lecture of day 4, lecture number 7 of this series, a lecture on statistical analysis in research, which will be delivered by Dr. Chintan Rajani, Deputy Director, School of Management, RK University. Sir is a master analyst and a passionate academician with a strong urge for learning new things all the time. He has done his PhD on users' behavior towards social media from RK University. He completed his Masters in Business Administration with Marketing Specialization from BK School of Business Management, Ahmedabad, and also qualified with DOE ACC A-Level and UGC Net Management certifications. He has total 14 years of experience working with industries and academics. He has also published and presented many research papers in national and international journals and conferences. He possesses expertise in the area of analytics, training, networking, and marketing. In the past, he has also headed the training and placement cell as well as the entrepreneurship cell of RK University. He also holds the privilege for being selected as a trainer for a prestigious international project named CAPSIN, funded by the European Union under the Erasmus Plus program, for which RK University was selected as one of the 5 universities from India. He has a rich experience of conducting training and development programs for students, faculties, and executives. So now let's hear it from Dr. Chintan Rajani. Thank you.
Hello, good afternoon everyone to all the participants. Thank you very much Devang sir for conducting the dots. I hope that you had a wonderful 3 days journey learning about different aspects of research methodology. Now today we are going to touch upon some of the very important aspects of statistical analysis and its importance in research. Reena ma'am has very nicely covered about literature review, and Kalani sir and Reena madam has also briefed you about various components of research methodology and research design. So once you finished with the collection of your data, next very important task is to how to proceed with this data. And there comes in picture the statistical analysis. So in next 40 to 45 minutes, I'm just going to give you a brief overview that how statistical analysis will help you in enhancing your research. I also observed that majority of the participants are novice to this research field, so I have not kept this presentation like to very tough or like tough level. I have kept it on a moderate level to help the novice researcher. So this is like a common picture in my classroom when I used to take statistics in my master's class, and I am very sure that most of the novice researcher like feels the same. Even I also passed from the same phase, that we just feel like these three idiots when we think about the various statistical tests and formulas. But let's hope that this session will definitely going to help you that how you can proceed with your data and you can do an excellent statistical analysis. This is another very interesting mime which is going on internet, that there is a person who used to think that correlation is just implied a causation. So then he took a statistical class, but still he is not very sure that correlation implied to causation or not. So his friend asked him, sounds like class has helped, but he is not sure. Well, maybe. The same thing, statistic is so wide field, and as we have learned from the yesterday's session of Dr. Priyanshu Rathod, that every day there is a new statistical tool and techniques which is coming up to help us in computing the data. So even after having a experience of more than 1 decade in this field, I am again not sure that I know everything about the statistics. So this is a common picture everywhere. So what we are going to learn today? We are going to learn about what is statistics, why it is important to learn statistics as a researcher, common mistakes done by novice researchers, what process to follow while doing a statistical analysis for research, classification of statistics, about hypothesis testing, various types of statistical tests used in hypothesis testing, and other important statistical tools. So let's start with what is statistics. Now statistics is a part and parcel of our daily life. Whether we visit a mall or whether we watch a cricket match, we often come across the different kind of statistics every day. But the perspective of statistics differ from person to person. For some person, it might be the branch of mathematics. For some person, it's just facts and figures, which you often see in the newspapers or magazines or research papers. For some persons, it's just a measurement taken on a sample. For someone like it's a type of distribution being used to analyze the data. Estimation and hypothesis testing. So these are all the common words which are associated with statistics. But if we want to define in a very precise way, we can say that statistics is a science of gathering, analyzing, interpreting, and presenting the data. So now, why it is important to learn statistics as a researcher? So statistical knowledge helps you use the proper methods to collect the data, employ the correct analysis, and effectively presents the results. Apart from that, we are seeing that there is a growing importance of decisions and opinion which was based on data. So it's crucial that you can critically assess the quality of analysis that has been presented to you every day. Third, it helps you to develop an ability to extract meaning from the journal articles and other newspaper articles, and the ability to critically evaluate such research from a statistical perspective. Because we are seeing that nowadays in most of the reputed research journals, each and every claim was supported by the statistical data. So it will help you in interpreting that data in an effective way. Next, it will definitely going to help you in developing a critical and analytical thinking. You can use the numbers, and the numbers always provides you a credibility in all the scientific studies. So what I want to say is that it helps in communicating your findings effectively, which will further help you in publishing your research work in a good and quality journal. So that's why being a researcher, it is very important for you to learn the statistics rather than running away from it. But still, there are some common mistakes which has been observed among the novice researcher while dealing with the statistics. So I'm just going to give you a glimpse of some of the common errors which was made by the novice researchers. First and foremost, error in identifying correct level of measurement of data. That means classifying a data in a wrong way. Next, applying a wrong statistical test without having a proper knowledge that whether a parametric or non-parametric which test is suitable, and without validating its assumption, a researcher used to apply a test which was known to them. So they often use some of the heuristics and biases while applying this kind of a test. Third, use summary measures inappropriately. Like but just giving some conclusion on the basis of average and not even considering the measures of deviation or standard deviation. Presenting a categorical data as a quantitative data, and apart from that using it for the further analysis. Inappropriate treatment of outliers and not reporting the outliers. This was again a very common mistake which has been observed nowadays. Incorrect interpretation of results. That means correlation is just implied to causation. Incorrect extrapolation. That means tempted to draw conclusion beyond what the data actually shows. And last but not least, statistical significance can be mistaken with the clinical significance. So gentlemen, there is a difference between statistical significance, but that statistically significant data may not be clinically significant or may not have a relevance in the business decisions. So these are some of the common mistakes which has been observed among the novice researcher. Now to avoid such mistakes, like we need to go methodologically while we are dealing with any kind of a data or planning to do some statistical analysis. So these are some of the steps which we need to follow while doing a statistical analysis. First is to identify correct level of measurement of data. Second, to know what is the objective of doing statistical analysis. What I mean to say is whether you are using a data to describe characteristic and make some conclusions out of that, or you are using that data to test some hypothesis and make some inferences, or you are using that data to make some predictions or develop some model. Once you are clear about your objective of using a data for statistical analysis, next you need to select a statistical tool and technique which is relevant for that analysis. Last, you need to do interpretation of the results to derive a meaningful conclusion. So these are the four basic steps which you need to perform while doing any statistical analysis. So let's start with the level of measurement. So what these two numbers represents, 10 and 40. 10 can be a jersey number of Sachin Tendulkar, or 10 can be a jersey number of Lionel Messi. 40 can be my enrollment number. 40 can be the number of deaths which has been reported in Nagpur. 10 may be like millions of crores of rupees in my bank account. So the same number represents different meaning when I talk in a different perspective. So it is just like we need to diagnose a data correctly. For example, when you go to a doctor and if you have a fever, they cannot directly conclude that you got a flu. They will ask you further questions in order to diagnose it correctly. Same way, being a statistician, first art which you need to develop is to diagnose the type of data correctly. So what this 10 and 40 represents? So there are four levels of measurement of data which we should aware about. First level of measurement is nominal level data, which is the lowest level of measurement. Nominal level of data are generally used for the purpose of classification or identification. For example, classification on the basis of gender. So if there are a number of patients, I just want to say that how many of them are male and how many of them are female. So the type of data which are used is a nominal data. Or for the purpose of identification, for example, bank account number. It doesn't mean that that much amount of rupees is there in my account. It just means that it is a unique identity number. Same way, PAN card, vehicle registration number, this all are different kind of data which are either used for the purpose of identification or classification, and they all falls in nominal level of data. But the problem with nominal level of data is that number does not have any meaning. What I mean to say is, suppose there are two students, one is having roll number 10 and second is having roll number 20. So it doesn't mean that roll number 10 is much more like studious in studies as compared to roll number 20. They are just numbers which are used for the purpose of identification. So that particular drawback of nominal data have been cleared in ordinal level of data. So in ordinal level of data, numbers have some meaning, and generally ordinal level of data are used to indicate ranks or orders. So the relative magnitude of number is now meaningful. For example, when I say that student has secured second position and another student has secured 10th position, it definitely has some meaning. That a person who has secured the second position have scored more marks as compared to student who has secured 10th position. So the difference between numbers are now comparable in ordinal level of data. Examples are ranking productivity of employees, rating, like again level of satisfaction in different kind of surveys in which you are participating, like officers rank or class in an organization, like class 1 officer, class 2 officer. These all are examples of ordinal level data. So nominal and ordinal both are also termed as non-metric. What I mean to say is the person who has secured second position and the person who has secured third position, they do not have the equal difference in the marks. So the difference between the two numbers are not equal. So that drawback has been addressed by the next level of measurement of data, which is interval. So in interval level of data, numbers are definitely having some meaning and distance between two consecutive integers are equal. So difference between two numbers are now comparable. But again, here a point which you need to note is that location of origin or 0 is arbitrary. So I will give you some examples of interval level of data like Fahrenheit temperature or calendar time. So when I say that 10 days from now, so you will fix a 0 to 26 and add 10 days. So you will say that on 6th of May. Same way, when I say after 2 hours from now, so you will fix a 0 to 5:15 and you are going to say that okay, we will meet at 7:15. So the 0 which we are taking here is arbitrary. Other examples is growth rate. So when we say that growth rate of COVID-19 patients in Gujarat is 6%, so here the base was not taken when the first case of COVID-19 was detected, but the base was taken the last year's figure. So again, growth rates, Fahrenheit temperature, calendar time, these all are examples of interval level data. Again, the drawback of interval level data, that means location of origin or 0 is arbitrary, is removed or addressed in the last level of measurement, which is ratio. So ratio is highest level of measurement. Here numbers are having some meaning. Distance between two consecutive integers are also equal. And third, location of 0 is natural 0. Examples is height, weight, volume, profit, loss, revenue, expenses. This all are data where we generally count from like natural 0. So interval and ratio both are termed as a metric data or quantitative data. So friends, these are 4 basics levels of measurement. So you must be able to identify the correct level of measurement when you are dealing with any data. So let's check that how many of you are able to identify it correctly. I'm going to show you some of the types of data or variables. You just need to identify the correct level of measurement of that particular variable. Ranking countries on the basis of number of tests done by COVID-19 patients. Yes, it is an ordinal type of data because a word ranking. Total number of new cases of COVID-19 patients. Yes, it is a quantitative data and total number we generally calculate from a natural 0. So it is a ratio kind of a data. Mediclaim policy number of a patient. Correct. So it is a nominal kind of a data, right? Okay. Total number of new deaths recorded on a particular day. So again, total number of new deaths recorded, again we are calculating from natural 0. So that is a ratio kind of a data. Rate of increase of COVID-19 patients in Gujarat state. It will be termed as a interval type of data because rates we are considering a arbitrary 0. Rating hygiene and cleanliness of COVID-19 dedicated hospitals. Rating, correct. It is an ordinal kind of a data. Date on which Mr. Ajay will complete his quarantine period. So again we are fixing a 0 on a date from when his quarantine period has been started. So this is a kind of a data which has been termed as interval level of data. Gender of COVID-19 patients. Correct. It is a nominal kind of a data. So this is how like we need to identify the correct level of measurement of the data. That is the first step which we need to learn in statistical analysis. If we are able to identify the correct level of measurement of data, then and then only we can able to identify correct treatment to be given on that particular data. That means what kind of statistical tool or technique which we can apply on that particular kind of a data. So once you are clear with the levels of measurement of data, next thing which we need to learn about classification of statistics. So broadly, we can classify statistics into 2 areas. One is called descriptive statistics and second is called inferential statistics. Now, in descriptive statistics, we are using data gathered on a group to describe or reach conclusion about the same group. For example, if I have collected a data of COVID-19 patients of Gujarat, then I will be making a conclusion about the patients of COVID-19 of Gujarat state only. I may not extrapolate it to Haryana, I may not extrapolate it to Mexico, I may not extrapolate it to West Bengal. So, collecting a data from a particular group and describing a characteristic or reach conclusion about the same group is a main characteristic of a descriptive statistics. Second very important classification of statistics is inferential statistics. Here we are using a sample data to reach conclusion about the population from which the sample was taken. So now we are randomly selecting some data from Gujarat, some data from Maharashtra, some data from Telangana, and trying to reach at a conclusion about the status of COVID-19 in India. So that is called inferential statistics, where we are predicting on the basis of sample. So what are different measures which you can use if you want to use descriptive statistics? Friends, it is very easy to use descriptive statistics when you are dealing with any data. So it has been classified into 4 different measures. One, measure of central tendency. Second, measures of variability. Third, measures of shape. And fourth, measures of association. Measures of central tendency gives you an idea about central part of data. And these are some of the common measures which we often use when we are dealing with measures of central tendency. Mode, which is nothing but highest repetitive frequency. Median, which is the middle part of a data. Mean, which considers all the elements of a data set and calculate the averages. Percentile, a particular position of a data. Same way, deciles and quartiles. In percentiles, we used to divide data into 100 parts. In quartiles, we used to divide a data into 4 parts. Second important measure is measures of variability. Sometimes it happens that by using only measures of central tendency, we may not be able to make some meaningful conclusion. So in that case, measures of variability comes very handy to make some effective conclusion out of that data or analysis. So some of the common measures of variability are range, interquartile range, variance, and standard deviation. Standard deviation is one of the most standard measures of variability which was widely used in all the fields of statistical analysis. Third is measures of shape, which gives you an idea whether the data is symmetric or asymmetric. So some of the common measures of shape are skewness, kurtosis, and box and whisker plot. And fourth, measures of association, which will be helpful in identifying the relationship or relatedness between the two variables or two data. So that can be measured with the help of coefficient of correlation, which is denoted by R. So level of measurement and descriptive statistics. So you cannot apply mean or standard deviation to nominal kind of a data. You can only apply mode. You can count the frequencies in a nominal kind of a data. Where in ordinal kind of a data, you can use median, minimum, maximum, and range kind of a descriptive statistics. In interval, you can do all ranking and counting and classifying plus addition, subtraction, multiplication, all kind of mathematical operations, and hence you can also able to use mean, variance, and standard deviation in interval and ratio, both which are called quantitative type of data. So we need to be very careful when we are dealing with nominal data, and we should never make a mistake to apply median or standard deviation when we are dealing with a nominal kind of a data. Again, use of standard deviation. So here I have given you an example that when I have used only measure of central tendency, that means mean, to measure that which of the stock or financial security among A and B will fetch me a good return, or it is a good investment option. So both are having the equal return. So it will be very difficult to make any judgment or reach at a conclusion that which is a better financial security among A and B. So in such cases, measures of variability like standard deviation will be very handy. As we can see from the screen that the standard deviation of security A is 3%, whereas standard deviation of security B is 7%. That means that B is more volatile as compared to A, or in other words, we can say that A gives more consistent return as compared to B. So with that, it will be helpful in reaching a conclusion that A should be preferred first as compared to B for further investment. Friends, another problem which arises when we are dealing with measures of central tendency and measures of variability is that suppose if mean is also different and standard deviation is also different. In such case, it is very difficult to make any decision. So there is one more measure of descriptive statistics which come handy in such situations, which is called coefficient of variation, which is nothing but ratio of standard deviation to the mean expressed as a percentage. Here again I want to give you an example that suppose there is one security which gives a return of 29% and a standard deviation of 4.6. There is another security which gives a return of 84% but a standard deviation of 10. If I only consider a standard deviation, that it may, and in first glance it may seem that A is less volatile as compared to B. But once we calculate the coefficient of variation, we can see that there is almost 15.86% of variability in A and 11.90% of variability in B. So even though the standard deviation of B is higher, but coefficient of variation is lower in B as compared to A. So this will be very handy when you are dealing with a data where you have different means and different standard deviation. If we talk about measures of shape, then this first three pictures show you the skewness. The central one is symmetric, almost both sides are equal. So that is called symmetric or not skewed data, where the S is the coefficient of skewness, which is 0. This side, this particular graph, right, their large number of data is on the right side of the mean. So that will be called negatively skewed data. If we say that number of deaths in USA which has been suffered because of COVID-19 as compared to other countries, we will see negatively skewed graph. Again, positively skewed data, where a large number of data is on the left side of the mean. When we say the result of a professional exams like CA, CS, where less number of students are qualifying, and we are seeing that large number of students are scoring a marks which is less than the average. So we'll see a graph like this, which is called positively skewed data. The same can be represented with the help of box and whisker. The below three pictures shows you a box and whisker plot. Here you can see that the middle line is in the right at the center, and these two boxes has been divided in an equal range. Here in a negatively skewed data, the central line or the mean line will falls on the right side of the data set, whereas in positively skewed data it falls in the left side of the data set. Another very important measure of skewness is kurtosis. So on the basis of kurtosis is nothing but it used to help us in identifying the thickness of the data or the spread of the data. So on the basis of that, we may able to identify three kind of kurtosis. One is called leptokurtic, second is called mesokurtic, and third is called platokurtic. And you are often seeing this kind of a charts in a newspaper or on a televisions, where and the objective is to flatten the curve. So platokurtic, where the spread is more, right, or the curve is more flattened, right, that will be termed as a platokurtic. Where in leptokurtic, the peak is very high and the curve is thin, right. In mesokurtic, it is almost seems normal. So these are the three very popular and standard measures of shape. So friends, I hope that you can able to apply descriptive statistics in your research. Now let us try to learn about inferential statistics. And before learning the inferential statistics, it is very important to learn about key terminologies which are used in inferential statistics. So let us start with the very first terminology. Before that, this picture shows that how inferential statistics work. Here we can find one employee and a boss. Boss is saying our big data analysis tells us that only the top performers leave for higher pay. So he has inferred that since you are still here, it means your performance is average at best. So employee replied, that's not fair. So again boss replied, that's what all the average people say. So this is how inferential statistics work. So when we talk about inferential statistics, the first terminology which comes to our mind is parameter and statistic. What is the difference between parameter and statistic? So parameter is nothing but a descriptive measure of population. It is generally denoted in Greek letters. Examples are mu and sigma. Mu is nothing but population mean, sigma is nothing but population standard deviation. Whereas statistics is nothing but descriptive measure of sample. It is generally denoted in Roman letter. The same examples we repeat here. Here x bar represents sample mean and S represents sample standard deviation. So process of inferential statistics work like this. You select a random sample. On the basis of sample used to calculate sample statistic. Here we have calculated sample mean. We used to consider that sample mean to estimate or make some predictions about population mean. So this is how the cycle works. Here the sample statistics has been used to estimate about population parameter or to make some inference about the population parameter. So let's talk about some of the other terminologies which has been used in inferential statistics. Hypothesis. What do you understand by hypothesis? Hypothesis is nothing but assumption or a tentative statements about the relationship between two or more variables. For example, some of the common hypotheses are like older workers are more loyal to the organization, or if there will be high rainfall, it will result into higher level of yields or productivity in the fields. So these are some of the basic assumptions which we are dealing on every day. If there is an increase in price of fuel, there will be a decrease in demand of vehicles. So these all are common hypotheses which we are dealing with. So being a researcher, you always want to examine that old beliefs or hypotheses. So there comes a picture which is called research hypothesis, which is nothing but a statement of what the researcher believes will be the outcome of an experiment or study. If you think that okay, old workers are not loyal to the employees, not loyal to the organization, you can test that hypothesis. You can make it as a research hypothesis. Once you formulate the research hypothesis, which are generally in form of statements, you need to go ahead and derive a statistical hypothesis. A statistical hypothesis is a more formal structure which has been derived from research hypothesis, where we used to divide it into two parts, a null hypothesis and alternate hypothesis. Null hypothesis generally resembles that nothing new is happening, and it was generally denoted by H0. Whereas an alternate hypothesis always says that something new is happening, or there is some new phenomena has been derived. It is generally denoted by HA or H1. So alternate hypothesis is always called researcher hypothesis. So whatever claim you want to prove, you always need to write it in an alternate hypothesis. Again, very important terminology is type 1 and type 2 error. When we are doing some hypothesis testing, we often make some errors in judgment. So that can be classified in two common errors, type 1 error and type 2 error. Type 1 error means when hypothesis is true but you are rejecting it. That means you have conducted a type 1 error. Type 2 error means when hypothesis is false, but still you are accepting it or you fail to reject it. It was generally denoted by beta. Whereas type 1 error, that means rejecting a true null hypothesis, that kind of error is denoted by alpha. Estimation, the process by which one make inferences about the population based on the information obtained from a sample. So estimation we already learned in that particular chart. So there where we have calculated sample mean is called point estimate, and with the help of point estimate we can able to derive interval estimate, which is nothing but a range of values calculated from the sample statistic and standardized statistics such as Z. After learning about point estimate and interval estimate, one of the very important concepts which we need to learn is confidence interval, which quantifies the uncertainty in the measurement. It is usually reported as 95% confidence interval, which is a range of values within which it can be 95% certain that the true value for the whole population lies. Again, next term is level of significance, which is denoted by alpha. The level of significance is the probability of rejecting the null hypothesis when it is true. So these both are again inverse of each other. When we say that there is a 5% level of significance, that means there is a 5% probability in error in our hypothesis testing. That means we are 95% confident of our claim. That means 1 minus alpha. So these both are having an inverse relationship, confidence interval and level of significance. Another very important concept is rejection region versus non-rejection region. Again, here you can see two types of charts, right? So here the area which was there in the white is called non-rejection region, and the area which has been marked in the red is called rejection region. So if your level of significance is 0.05 and if you are dealing with two-tail hypothesis, then you have a rejection region on both the ends of this particular normal distribution chart. So 2.5% on the left side and 2.5% on the right side. When you are dealing with one-tail hypothesis where you are not supposed to divide the alpha, there will be rejection region on only one side. As we can see here, that red portion has been marked on only right side of the tail. So these are some of the graphs which represents one-tail as well as two-tail hypothesis. Null hypothesis is generally written in the form of equal to. So suppose if I want to test a hypothesis that whether a packet of wafer which I am purchasing is having the quantity of 40 gram or not. So my null hypothesis will be H0 equals to 40 gram. So suppose if I want to make a claim that I am not getting the right quantity, then my alternate hypothesis will be H1 is not equals to 40 gram. So in that case, when I am using not equals to, that means the rejection region is on both the sides. Whether the outcomes comes that there is a more quantity as compared to 40 gram or less quantity as compared to 40 gram, in both the cases I am rejecting the null hypothesis. That means it is a two-tailed hypothesis. But suppose if I am only interested to prove that I am getting a lesser quantity than 40 gram, then I'll be interested in this particular area which is called left tail test. I want to prove that it is less than 40%, which is the average claim which was made by the manufacturer. Whereas manufacturer will be interested in proving that okay, the quantity will be at least 40 gram or more than that, then he will be having a right tail test or having a rejection region on the right side. It will be denoted as H1 mu is greater than 40, whereas in my case it will be H1 mu is less than 40 gram. So these are one tail and two tail test. Once we are aware about the basic terminologies, then let us learn about different steps which we need to perform in hypothesis testing. First, we need to establish a hypothesis. That means state null and alternate hypothesis. Step number 2, once you able to define null and alternate hypothesis, you need to determine appropriate statistical tests for the sampling distribution. That means whether Z test will be applicable, T test will be applicable, or ANOVA will be applicable, which test will be going to be applied here. After that, you need to specify the level of error. That means alpha. It may be standard error, which generally used to be taken is 5% level of significance, but you can take 1% level of significance, 10% level of significance, depends on the type of study. Then you need to calculate the value of test statistic. That means suppose if you are dealing with doing a hypothesis testing for mean, then you need to calculate the sample mean. If you are dealing with the hypothesis testing of proportion, you need to calculate sample proportion. Then you need to establish a decision rule, and on the basis of decision rule, you need to state a statistical conclusion. Let us understand that by one example. Okay. So before that, again, we have learned here that we need to go for a statistical test. So in inferential statistics, there are two broad classification of test. One is termed as parametric test, and second is non-parametric test. If we want to deal with parametric test, we need to fulfill the assumption. First, we need to check whether the data has been normally distributed or not. Second, whether the variance is homogeneous or not. And third, whether the level of measurement is interval or ratio or not. If you are fulfilling these three requirements, then you can go ahead and use any of the parametric test. If your data is not normally distributed, if it do not have a homogeneous variance, or if the data is not quantitative, that means it is a nominal or ordinal data, then in such cases you need to go ahead with a non-parametric test. So common statistical tests we are going to learn in the next slide. So these are some of the common statistical tests, and we'll zoom it so that you can see it. So this is a flowchart that which statistical test you need to use, what type of data you have, whether the data is continuous or whether the data is discrete. Again, suppose there is a continuous data, then again you need to check whether it is a normally distributed or it is a skewed or not normally distributed. Suppose if it is a normally distributed, then you are testing for a one particular group or one population, or it is for two population, or it is for more than two population. If you are doing a hypothesis testing for one population, again you need to check whether the sample size is greater than 30 or sample size is less than 30. If sample size is greater than 30, then you can go ahead and use Z test. If sample size is less than 30, then you can use T test. In both the cases, the hypothesis, null hypothesis is mean is equal to given constant. If you are dealing with two groups, then again you need to check whether the data is paired, that means before after kind of a study, or data is non-paired. If data is paired, then you can use paired T test. If data is non-paired, then again you can use T test. These are the hypotheses which we are using in both the kind of tests. In case of more than two groups or more than two populations, you can use ANOVA kind of a test, which is called analysis of variance. If there is a discrete data, then again in case of two groups, non-paired groups, where expected count should be more than 5, should be greater than 5 in 75% of the cells, you can use chi-square test, and hypothesis will be proportions are equal. Same way, in case of non-paired test, you can also use Fisher and exact test. In case of paired kind of a data, you can use McNemar's test or chi-square test. In case of proportion, again you can go ahead and use binomial test or p-test. So these are some of the basic statistical tests which you can use. Let us understand with one of the example, entire hypothesis testing with one of the example. Here there is a case, the Food and Nutrition Board of National Academy of Science state that recommended daily allowance of iron for adult female under the age of 51 is 18 milligram. A sample of iron intake was obtained from during 24 hours period from 45 randomly selected adult females under the age of 51. It revealed that sample mean was 14.68 milligram at the 1% level of significance. Thus, that data suggests that adult females under the age of 51 are on average getting less than the RDA, that means recommended daily allowance of 18 milligram of iron. Assume that population standard deviation is 4.2%. In this case, the population mean is 18 milligram, the size of sample is 45, the sample mean which has been calculated is 14.68, level of significance, that means alpha is 1%, and here the hypothesis we want to prove that the average RDA is less than 18 milligram. That means our hypothesis is one tail test, which is a left tail test, and the population standard deviation, that means sigma, which has been given here, is 4.2 milligram. So quickly just see step by step. Here we have formulated the hypothesis as 0 mu equals to 18 gram and mu is less than 18 gram. Step number 2, decide on level of significance. Here it has been given that 1% level of significance. Step number 3, compute the value of test statistics. So here the sample size is larger than 30, so we are going to use Z test. So this is the formula of Z test, and the calculated value of Z is minus 5.30. Since it is a left tail test, so the rejection region is on the left side, so it is just on the one side. So this is the again left tail test. So we are just going to compare that. As we can see that we need to compare this calculated value, that means minus 5.30 with the critical value minus 2.33. That means at this point it is 2.33 and minus 5.33 falls in a rejection region. So we can conclude that the null hypothesis will get rejected. So this is the conclusion. At 1% significance level, the data proves that sufficient evidence to conclude that adult females under age of 51 are on average getting less than the RDA of 18 milligram of iron. This is how the entire hypothesis testing process works in different steps. So again, there are more topics to be discussed, but we may continue on some other another way. Like again, in regression analysis, which is a very useful tool for prediction of a data, wherein there are two types of variables. One is called dependent variable and another is called independent variable. This is an equation of simple regression, right? Where y is a dependent variable and x is independent variable. This is the output of multiple regression, where there are some of the important things which we need to consider, like R square, which is nothing but percentage of variability explained by the regression model. The p-value, which is a very important concept, which denotes that on the basis of which we can decide that whether the hypothesis will be rejected or not. Here we can see that two independent variable, temperature and humidity, for both the p-value is less than 0.05, that means less than 5% level of significance. So temperature, we can say that it is a good predictor, whereas in humidity the value is 0.44, which is larger than 0.05, that means 5% level of significance. So we can say that it is not a good predictor. So again, this is a summary, like of parametric and non-parametric tests. Again, this often comes when I used to deal with statistic. I did a statistical analysis and found that there is no correlation between my efforts and my rewards. Friends, I think that 45 minutes is very less to learn in detail about the statistical analysis. There are so many different tools which are yet to be learned, but which can be further covered in future webinars. Thank you very much for have a patient listening, and I hope that this session has added some value, and you will be confident that how to deal with some data and can perform some useful statistical analysis. These are some of the more tools which you can use for analysis, like logistic regression, discriminant analysis, factor analysis, confirmatory factor analysis, cluster analysis, and so on. Thank you very much. Now we have very less time for question answers. you can definitely drop me your questions on my email ID, which is chintan.rajani@rku.ac.in. Now I'll be able to take few of the questions in a very limited time. Thank you very much for a patient listening once again. Okay, now I'm trying to answer some of the questions. How the various tests can be decided. Example, t-test, z-test, one-way ANOVA. As I have described, that first step, what you need to do is like you need to check for the level of measurement, whether the data which you are dealing is a metric type of data or non-metric type of data. If it is a metric type of data, second thing which you need to do is you need to check for the normality, because in most of the parametric tests, we assume that data is normally distributed. So yesterday Priyanshu sir has explained that how to check for the normality of the data. So if once it has been proved that your data has been normally distributed, and the third assumption, which is the equality of the variance, if all the three assumptions has been fulfilled, then you can go ahead with any kind of parametric test. In particularly z-test and t-test, both can be used for comparing the means. When you have a sample size which is larger than 30, you can go ahead with the z-test. In case there is a sample size which is small, which is less than 30, you can go for t-test. Once again, I repeat that both can be used in case of comparison of means or proportion. One-way ANOVA can be used when you are dealing with more than two population. That means your hypothesis is mu1 is equals to mu2 equals to mu3 or and so on. So when you are dealing with more than two population, you can use one-way ANOVA. Another question, again, another question is in research work, which level of data we have to use? So that is a very important question which need to be taken care at the time of designing an instrument for your research. So suppose if you are dealing with the questionnaire, then you need to be very careful in identifying that what kind of questions you need to put. For example, if I'm putting a capturing a data like marital status, that means I'm capturing a nominal kind of a data. If I'm capturing a data of a age, that means I'm capturing a ratio kind of a data, right? Same way, if I'm using a rating scale or Likert scale, that means I'm capturing an ordinal kind of a data. So at the time of designing a questionnaire, you need to be very careful that what level of data you are capturing, and on the basis of that, it will be decided that what kind of statistical tools or technique which you can use to make some conclusion about your research. I will go to next question. Why standard deviation is more important? Because gentlemen, it is one of the most standard measure of variability. There are some other measures like mean absolute deviation, right, which is the difference between the mean and a particular data set. But again, we need to do the absolute value, calculate the absolute value in order to calculate mean absolute deviation. Whereas in standard deviation, we used to square the value, and then probably after that we are again taking the under root. So this is one of the most standard measure of variability. That's why standard deviation is very important in the study. Okay, I may take one more question, like how to infer p-value in the test results. Now p-value is very important in most of the statistical output, maybe by SPSS, or maybe if you can perform with the help of Excel, you can generally get the p-value. Now p-value is nothing but you can compare the p-value with the level of significance. For example, suppose if I am taking level of significance equals to 5%, that means 0.05. So in order to reject the null hypothesis, the p-value should be less than 0.05. That means 5%. If it is larger than 5%, then I may not be able to reject the hypothesis. Same way, suppose if I am taking a p-value, level of significance equals to 10%, then in order to reject the null hypothesis, my p-value should be less than 10. So p-value is very important indicator to decide whether to reject or whether you fail to reject the null hypothesis. So there are many more questions. I am very sure that you are going to mail me your questions, and I put my best efforts to reply to all their queries. Once again, thank you very much for listening me patiently, and all the best for the next session. Thank you.
All our research, all our efforts are null and void without statistical analysis. Thank you, sir, for highlighting the fine points regarding it with such an in-depth understanding. The kind of examples that you have given and the the kind of calculations that you have been able to show us, it has been really an excellent lecture. The question answer session has also been very engaging with active involvement by all the participants. So we end today's first session over here. We'll take a short break and be back by 6:15 for the next lecture to understand the various journal metrics and then to go on and try and learn how to identify good journals for publication. See you all there. Thank you.